Okay guys, today's lesson is going to be a follow-up from yesterday's. You are going to be finishing up your mapping volcanoes and earthquakes lab, and what you're going to do today is you are going to map what you didn't map yesterday. So if you only got started a little bit, like some of the classes, you are going to go ahead and I want everybody to map at least 20 earthquakes and 20 volcanoes. I challenge you to map all of them, but you also want to leave yourself some time to work on the questions and get them done before you leave class today. So at a minimum, I would really like you guys to get 20 and 20. If you're struggling, get 10 and 10. And if you're doing awesome, you're cranking right along. And if you're working with a partner today instead of by yourself, one thing that I observed was one person would read the lat and the long, and another person would start plotting it, and then they would switch. And that seemed to work really well yesterday. So your choice today is you've got your headphones on, and you can decide to do this on your own today or to work with your elbow partner. You're not going to get up and walk across the room and work with somebody else. You're going to work with yourself or with your elbow partner. So your choice, but just a review. Challenge 45 and 45. Minimum 10 and 10. And the happy maybe in between point would be 20 earthquakes and 20 volcanoes mapped. So you have some time to work on the questions. Okay, I'm going to quickly review how we did that because yesterday was a long time ago and there were some people absent. And then you guys are going to get to work today. So let's take a look at yesterday's map. I'm going to do a quick review of how to map earthquakes and volcanoes. And let's see if I can get this going here. Here we go. All right, so remember, you are going to need this physiographic chart of the seafloor. And we got a little bit of a glare going on here, so bear with me. You need 2 markers and everything's color-coded. You guys are going to use the green earthquake data list with the green marker. They're rolling away on me for earthquakes. And you're going to use the pink list and the red marker to map volcanoes. Now, all of this is listed in your procedure, which is in Schoology. So there's no paper today. You are mapping, you're answering questions in Schoology, and then you're going to hit submit. And if you don't get to the questions, then you are going to do them as homework. All right. And there are some questions, the challenge questions, which will be optional. All right. So let's go. Quick review on how to map the latitude and the longitude. Now, remember that our planet is divided in half by the equator, if you will. That's 0 degrees. And on the top half are the northern latitudes, and on the bottom half are the southern latitudes. So when you look at these plots of where these earthquakes and volcanoes have been happening, remember that N is for the north, the top half of the latitudes, and that's the latitude. LA comes before LO, so latitude, longitude. 117 west, ignore the decimal points. It's okay. 117 west. Now, what does that mean? So there is an arbitrary line that runs right around here. Here we go, right around here by England, through Sandwich or Greenwich? Greenwich, England. And it's called the Prime Meridian. And to the right, well, I guess it depends on which way you're looking at it, but on one side are the eastern longitudes, and the other side are the western longitudes. So the planet is divided in half north-south and in half again east and west. On your map, it's a little confusing because remember, we're looking at a 3D. We're taking a 3D object and putting it into the 2D, and where it was cut in half is not directly in half, so half of your map are the eastern longitudes and the other half are the western longitudes. So that's why you have east, west, east. But if that didn't make any sense, it's a-okay. You just need to keep track of where those letters are so that you are making the right plot marks on your map. So at a minimum, plot 10 earthquakes and 10 volcanoes and take a look at your data. If you have neighbors nearby that are doing more, take a look at their data as well today. But I want you guys to be examining and looking for a relationship between volcanic activity, earthquakes, and plate tectonics. And when I come back on Wednesday, we'll talk about it. So I hope that was helpful. Let's quickly review how to do this, and then we'll move on. So some of you had different methods. I like this method. I use the top of my map to keep track of where I'm going. So let's see here. Let's make sure you guys can see me. I can see you. All right, first, 34 north. So 34 north, I'm going to look for the N for north, my northern latitude. So I'm going to find my 34 in my northern latitudes, and I'm just using the ruler, cheating. I'm just using the ruler to kind of keep track of where I'm going. The clear rulers are a little bit easier, and see that's kind of tilted, so I'm going to push that up just a little bit, and that's pretty even. Okay, and so that's on 34 north. Now my second number is 117 west, so I'm going to look, that's my longitude, so I'm just going to look for my east, my west, here's my W. So here's my W, there's a W, here's my W. So 117, where is that going to be? There's 50, 60, 70, 80, 90, 100, 110, 120. Okay, I know it's somewhere here between 120 and 110. So I'm going to use this edge of my ruler to line up to 117. It's about there. And it's okay if it's not perfect, just as long as you are in the general vicinity. So the top part represents 34. This inside represents 117. And I'm going to put my dot, bonk, right there. And that is where this earthquake occurred in Los Angeles, California on January 9th in 2009. Okay, don't worry about magnitude. We're going to talk about that later this week. Remember, this week is all about volcanoes and earthquakes. Alrighty, so there's my first plot. Now, one complaint that I had was they smudge. Why can't we do this on paper? Well, it is paper, it's just laminated, and we're reusing it. So just make the best of it, and remember to map all of your earthquakes in green marker so that your key is accurate. Green for earthquakes, and then when you're ready, you're going to use red for volcanoes, because you know, lava. All right, so pause this video, go ahead and map your earthquakes and your volcanoes, and you're going to map both on the same map. So if let's say I had 10 or 20, or I got all of them done, and I was ready to do my volcanoes, you're going to have red and green dots on this map. So I'm just going to map this volcano because volcanoes are pretty awesome. And it's in Indonesia. And you're like, I don't even know where these places are. That's okay, because you're using the latitude and the longitude to find where in the world these places are, which is kind of cool. So you're going on a little global adventure, looking for earthquakes and volcanoes in a way. All right, so this is cool. I'm almost on the equator. So 1 degree north, just north of the equator, and 124.7 degrees east. So I can round that to 125. And remember, it's east, so don't plot it on the western latitudes. So I'm going to go find north, 1 degree of north. So basically I'm on 0, somewhere around here, and 125 east. So here we go. Got 125 is going to be right about here. I'm going to go on the inside. So this is the inside of my ruler. Top part is 1 degree. I'm going to drop my dot right there. And that is the location of one of these volcanoes. I'm going to go for at least 9 more. Happy medium would be about 20. Alrighty, so I'm going to stop talking. This is procedure part 2. When you are ready, come back. And we are going to do procedure 1 real quick. I think my first period class is the only one who kind of walked through that, but I'm going to have everybody do it. So please complete procedure 2 first, and then unpause the video and come back for procedure number 1. Now, before I forget, I do want you guys to take a picture of your map again today. So before you erase it today, take a picture, just like you did yesterday. Copy and paste it into your answer sheet. And so there should be 2 pictures for everybody unless you are absent yesterday, which most of you guys were here. All right, pause and come back when you are ready to move on. So go plot at least 10 volcanoes, 10 earthquakes, and then come on back. All right, you guys are back. So your map is completed. Don't erase it yet. And what I want you to all do with your elbow partner is I want you to get one of these bags and a roll of tape that's on the back counter. So keep your map, don't erase it yet, because you're going to see how these two things are connected. So this is kind of like the big reveal, and then we'll work on questions. So take this bag, empty out those puzzle pieces, and I want you to put them together. They're plates, they're tectonic plates, and sorry, they don't lay flat, just do your best. And I want you to put them together so that they are all one big piece of Earth's crust. And once you think you have them all together, go ahead and tape them and check back in. So pause, go put the pieces together, tape them together, and then check your work with mine in a moment. So pause, put them together, and then come on back to check your work. Okay, let's see how you did. So you have your map all taped together, and I want you to put it on top carefully so you don't lose your volcano and earthquake plots, but it should fit on top of your physiographic map. And it's okay, it's not going to fit over the 0 to 30 east longitude, and that's okay, but it should fit everywhere else. So let's take a look at this. So you have, this is maybe a different way than what you've seen. I'm going to tape this one other piece that was kind of popping up and bugging me. Stay down. Alrighty. Well, it's not perfectly flat, but I think you get the picture. So check your work, check your map. How'd you do? Hopefully it didn't take you very long, and you did great. In the middle here, we have the big Pacific plate. North American plate, everything is labeled here, and it might be in a slightly different place than what you're seeing it, because each map can be different depending on where it's cut. Now, take a look at where the plate boundaries are. These lines represent, remember, tectonic plate boundaries. And that's what last week's lab was all about with the graham crackers. The transform, the convergent, where they're smashed together, and we got graham cracker mountains, and the divergent, where they are pulling apart, and we got that mid-ocean ridge with the strawberry yogurt. So these represent those plate boundaries. It doesn't tell you which type they are, but it does tell you that here are the plate boundaries, the tectonic plate boundaries of our world. There's little plates like the Cocos Plate and the Caribbean Plate, the Scotia Plate, the Philippine Plate. Then there's really big plates, our major plates, Pacific, North America, Eurasian, and the Antarctic. So what I want you to do is take a look at this puzzle and take a look at where you have those volcanoes and earthquakes. And now I want you to go and answer those questions to the best of your ability in your lab, the post-activity. What relationship can you make? What connections do you see between the physiographic map and where you plotted the volcanoes and earthquakes and where there are known plate boundaries? Okay, so you are going to pause the video. You are going to go work on those questions and then come on back. All right, so you have been working on the questions. Just a quick reminder, make sure that you have taken a picture of your map and copy and paste it into the red box with the camera reminder. Everyone, please work on questions 1, 2, 3, 4, 5, and 6. Notice it says you may use your textbook to help answer 6A and 6B. You can use your textbook to help you answer any of these questions. So do your best to answer numbers 1 through 6. Everybody, I'm expecting you to try those out. They are due tomorrow if you don't finish them in class today. Now, if you have time and you are interested, you can work on the earthquake challenge questions. To work on the earthquake challenge questions, you will need one of these charts that gives you some additional information about earthquakes, and talks about Richter magnitudes, which we are going to get into later this week. So if you have time, go ahead and try these challenge questions, and if you don't have time, it will not count against you. Don't forget to hit submit. And my advanced science students, if you are still here and you have time remaining, go ahead and use remaining time to work on your science fair topic forms, which are due Friday. All of my students, I hope you started seeing some interesting connections between plate boundaries and earthquakes and volcanoes. For cleanup today, please make sure that you take all of the tape off of these puzzle pieces that you taped very carefully together. Oh no, I already ripped one. Dang it. So just be careful. Don't rip it like Miss Height Susan. Please put all the puzzle pieces back into the bag. Return them where you got them. Please use the rags to erase your maps. Put a little elbow grease in there to make sure all the dots come off. And that's it. So you have all the information you need. You may use your book to help you answer any of the questions. Please work quietly, and if you have questions, please ask the teacher. If you have additional questions, you can always send me an email, and I will be back tomorrow. All right. Thanks for your time and attention, and I hope that was helpful, and I'll see you soon. Thanks.